If there's one area on the PEBC evaluating exam you absolutely cannot afford to guess through, it's calculations. Under the current blueprint, calculations are flagged as must pass, meaning weak performance here can cost you the entire exam, even if you're strong everywhere else. In the next few minutes, I'm going to walk you through the core calculation types, show you worked examples, and point out the mistakes I see students make over and over again. Let's get into it. Let's start with the why. Under the current blueprint, certain competency areas are designated must pass, and calculations is one of them. That means if your performance in this area falls below the standard, you can fail the exam regardless of how well you did elsewhere. It's not there to punish you, it reflects real practice. A dosing error in pharmacy can be life-threatening, so the exam holds you to a higher bar here. The good news? Calculations are completely learnable. There are a finite set of question types, and once you've worked through enough examples, the patterns become second nature. That's exactly what we're going to build today. Before you can practice effectively, you need a map. Calculations on the EE generally fall into 4 buckets. First, dose calculations. Think mg per killing, pediatric dosing, BSA-based regimens. Second, compounding and dilutions, alligation, serial dilutions, mixing 2 concentrations together. Third, pharmacokinetics, creatinine clearance using Cockcroft-Gault, half-life, loading and maintenance doses. And fourth, concentration expressions, percent weight and volume, ratio strengths, molarity, and osmolarity. You don't need to master every subtype in one sitting. Knowing this map tells you where to focus and helps you notice when a practice question is testing a specific bucket rather than general math. Let's work through a weight-based example together. A prescriber orders a drug at 5 milligrams per kilogram per day to be given in 2 divided doses. The patient weighs 68 kilograms. Step 1. Multiply the dose by the weight. 5 times 68 gives you 340 milligrams as the total daily dose. Step 2. Divide by the number of doses. 340 divided by 2 equals 170 milligrams per dose. Simple chain, right? Where students go wrong is they forget to divide by the number of doses, or they flip the question and calculate a single dose when it asked for the daily total. Always reread what the question is actually asking before you write your final answer. Creatinine clearance comes up frequently in pharmacokinetics questions. The Cockcroft-Gault formula looks intimidating but has a clean structure. 140 minus the patient's age, multiplied by their weight in kilograms, divided by 72 times the serum creatinine in milligrams per deciliter. If the patient is female, multiply the whole result by 0.85. So for a 60-year-old woman weighing 70 kilograms with a serum creatinine of 1.2, you get 140 minus 60 equals 80, times 70 equals 5,600, divided by 72 times 1.2, which is 86.4. That gives roughly 64.8 milliliters per minute. Then times 0.85 equals about 55 milliliters per minute. From that number, you determine whether a renal dose adjustment is needed. Practice this formula until the steps flow automatically. Alligation trips up a lot of students because it feels counterintuitive at first. Here's the clean version. You're mixing a higher strength solution and a lower strength solution to get a desired middle strength. Write the higher strength on the top left, the lower strength on the bottom left, and the desired strength in the middle. Then subtract diagonally. Higher minus desired gives you the parts of the lower strength solution you need. Desired minus lower gives you the parts of the higher strength solution. Add those parts together for your total, then set up a simple ratio to get actual volumes. The key habit: always do your subtractions diagonally and never convert to volumes until you've finished the ratio step. Rushing that last conversion is where arithmetic errors sneak in. Concentration language is a mini vocabulary you need to be fluent in. Percent weight in volume means grams of solute per 100 milliliters of solution, so a 2% solution contains 2 grams in every 100 milliliters. Ratio strengths like 1 to 1,000 mean 1 gram in 1,000 milliliters, which equals 0.1%. Knowing how to flip between these two expressions is a fast point saver. For molarity, divide the mass in grams by the molecular weight to get moles, then divide by the volume in liters. Osmolarity adds one more layer. You multiply molarity by the number of particles the compound dissociates into. Nail these conversions cold, and you'll handle the concentration expression questions confidently, rather than re-deriving them under time pressure. Let me save you some easy marks by naming the 3 mistakes I see most often. Number 1, unit mismatches. You set up a perfect calculation, but one number is in micrograms and another is in milligrams, and you forget to convert. Circling your units before you calculate takes 5 seconds and eliminates this. Number 2, skipping clinical context adjustments. A question gives you a creatinine clearance result for a reason. If you ignore it and dose as if the patient has normal renal function, you'll pick the wrong answer. Number 3, answering the wrong question. The STEM asks for the single dose and you calculate the daily total, or vice versa. Underline what is being asked before you start the math. These aren't knowledge gaps, they're attention habits, and habits are trainable. Here's how to turn this knowledge into real exam fluency. First, always practice under a time constraint. Give yourself roughly 2 minutes per calculation question so you build the pace you'll need on exam day. Second, write your key formulas, Cockcroft-Gault, alligation steps, concentration conversions from memory every single study session. The act of retrieval locks them in faster than rereading. Third, make unit analysis non-negotiable. Write the units in every step of every problem. And fourth, when you get a question wrong, don't just check the correct answer. Trace back through your process to find where the logic broke down. That's the rep that actually improves your score next time. That's a wrap on must-pass calculations for the PEBC Evaluating Exam. Remember, this category rewards consistent practice more than raw talent. The patterns repeat, and every worked example you do makes the next one faster. If you want to go deeper, we've put together a detailed study guide and question bank specifically for the EE. You can grab it on our Etsy shop. The link is right in the description and pinned in the comments below. Got a question about a specific calculation type or a mistake you keep making? Drop it in the comments. I read every single one, and I'd love to help you work through it. And if you haven't subscribed yet, hit that button now so you're the first to know when new study videos go live. Good luck. You've got this. If this helped, check out these other PEBCBuddy videos to keep your prep going.